So this week we're gonna be extending our last week's lesson, which is factoring. And this week we're gonna introduce some new types of factoring. So like perfect square trinomials and other things. So firstly, we're gonna do some review from last week. Remember that last week we did a lot of factoring practice. So this week we're gonna start off by letting you guys solve a couple of factoring questions. We could do our first example. It could be x squared plus 9x minus 10. And if you're done, you can just type your answer into the chat. Oh, also, if you aren't here last week, then you can go to our YouTube channel. We have all the videos linked there. X plus 10 times x minus 1. Yeah, good job. So how we would solve this is first by factoring out the GCF, but since there is no GCF, we start off by writing the general form, which is x plus a times x plus b. Then we have a plus b is equal to 9, and a times b is negative 10. So then the two numbers that we find is 10 and negative 1. So we get x minus 10 times the x plus 1. David, do you want to do another one?
Yeah, okay, we can do one with the leading coefficient. We can do 2x squared plus 7x plus 5. Yeah, 2x squared plus 7x plus 5. Yes, that will be correct.
Yeah, good job.
That was fast.
That was, yeah. Do you want to explain it?
Yeah, okay. Oh yeah, let's explain using your method. I'm gonna try it again. Okay, so we first write out 2x, and then blank, and then the second expression, which is x, and then blank again. Oh, and then plus a and plus b, forgot about those. And then here we have a plus 2b equals to, yeah, a plus 2b is equal to 7. And then a times b is equal to 5. Wait, is this how you do it?
Yep.
Okay.
Yeah, it's equal to 5.
Good. And here we can see that a would have to be 5, and then b have to be 1. And then we write it back out, substituting a and b with the numbers.
Okay, I think that's enough reveal for last lesson.
Okay, should we move on to like what we're talking about today?
Yes.
Okay, so in the last lesson, we talked a little bit about how to like, well, actually, did we? No, we really didn't. But like, okay, we kind of talked about this method where we're using like a plus b and a times b to like solve a factor out a quadratic. And with this quadratic, and the way, okay, the reason we use this method is because the two binomials we multiply together are different. So for the examples we had above, we had like x plus 10 and x minus 1. But in some cases, we could have a trinomial that is the quadratic that can be formed by an expression like a plus b squared. So the two binomials are the same. So in this case, we could kind of use a shortcut by remembering a little formula. So we can have, wait, okay, let's write it out. So we have a plus b squared. And what we can do is that we can FOIL this out. So in the end, we get a squared plus ab plus ab plus b squared. And it just simplifies down into a squared plus 2ab plus b squared. So we can actually use this to simply like easily expand and factor any like trinomial that is in the form of a plus b squared. So we can do a little example. So if we have something like x plus 1 squared, instead of foiling that out, what we can do is that we could use the formula above. We could replace a with x, so we get x squared. And then what we do is that, I'm pretty sure, yeah, 2, and then what we do is that 2 times x times 1, and then plus, and then 1 squared. So that's an easy way of simplifying it. And in the end, we get x squared plus 2x plus 1.
I think we should explain what a perfect square trinomial is.
Oh yeah,
So,
that's a good idea.
yeah, so recalling junior high, how you've learned that hopefully that a number squared, such as 5 squared, is 25. We say that the 25 is a perfect square. However, in the case of trinomials, there isn't a number that could square itself to get to a trinomial. So then we would say that a binomial squared can give you a trinomial. So for example, 2x plus 3 squared is equal to 4x squared plus 12x plus 9. So then we call this a perfect square trinomial. So in summary, a perfect square trinomial is a trinomial that can be expressed as a binomial multiplied by itself. So a perfect square trinomial.
What's a trinomial?
Oh yeah. So a trinomial is any expression with 3 terms. So for example, we can have
Try, not try.
sorry.
It looks like try, not try.
Oh, sorry. Trinomial. Yeah. Okay. Trinomial that can be expressed as a binomial multiplied by itself. Okay.
Should we try another expanding question?
Sure.
We can do like 2x minus 3 squared. Should we do this one together?
I think we should, yeah.
Yeah, okay. So as above, the formula we got, we do the a here will be 2x. So we do 2x squared in brackets. Remember the brackets? And then what we do is that we do 2ab, and the a will be 2x, and the b will be negative 3. So we multiply those together. And then the b would still be negative 3, so we do negative 3 in brackets squared. And in the end, we get 4x squared plus, negative 12x plus 9.
So in this case, we would say that this is a perfect square trinomial. Because it comes from a binomial multiplied by itself.
Yeah,
Okay.
and I guess a nice way to tell if it's a perfect square trinomial is if the first term in the trinomial and the last term in the trinomial are perfect squares.
Oh yeah.
So in this case, we have 4x squared and then 9.
That I don't think that's always the case because the middle
Yeah.
number could be like negative 13x, right?
Okay,
And
yeah, that is very true.
yeah.
Yeah, wait, that was kind of bad advice.
Yeah, it's fine. Okay.
Should we do more examples?
Yeah. We can do one more expansion
Okay.
example. So we could do you want to let students try out?
Yeah, we can let them try it out. We could get like 3x minus 4y squared. You have 2 variables now.
Wow, tricky. So expand this, and you can type your answer into the chat. Uh, 9x squared minus 24x. Close. Really close. Plus y. It should actually be 9x squared. Yeah, 9x squared minus 24xy plus 16y squared. Yeah. Yeah, it's fine, Edward. It's fine. All good. So I'll actually do this a little differently by using different colors. So 3x minus 4y. Great. Should I explain it or?
I can explain it.
Oh yeah, sure.
Okay, so here the term in blue would be the a. So what we do is that we do a squared, which is 3x squared. And then what we do is that we multiply a and b and multiply by 2. So here the b is 4y. So we do 2 times 3x times 4y. And then now what we do is that we add on negative 4y squared. Wait, forgot the negative.
Oh yeah.
Yes, always remember the negative, negative 4y. And then we add, oh, wait, okay, yeah. And then we add negative 4y squared. And then we just simplify this expression, and then we get 9x squared plus, oh, wait, it's not plus, there's a negative sign in there.
Oh yeah.
Okay,
Okay.
then we get 9x squared, subtract 24xy plus 16y squared.
Yeah. I mean, you could do this perfectly fine if you use the FOIL method, but if you want to do it a little bit quicker by memorizing a formula, then you could also do it this way. But I mean, if you really prefer the FOIL method, you can go ahead and do that. Okay. Should we move on to like factoring?
Yeah, we should.
Okay.
So yeah, using this method, we can also factor a perfect square trinomial because we have a kind of a formula laid out. So we can do a simple example to illustrate these steps. So we can have like x squared plus 6x plus 9. So remember that in a perfect square trinomial, the binomial is the a term in the binomial and the b term in the binomial are squared. So here we can kind of tell that a will be x because, yeah, just overlay that on top. And here we can see that the x squared will be the a squared term. So we can start writing out the binomial. So a will be x. And then here we can see that b squared is equal to 9, and then b will be 3. And then we can kind of put it into the binomial. So we can have x plus 3 squared. And then here we have to double check that it is actually the correct answer. So we could do the middle terms, which is 2ab.
Yeah, so 6x.
Yes. And then we see that it does match. So this is the factored form of that trinomial.
We could probably do another example.
Yeah.
Don't know, go with 49x squared minus 56x plus 16.
Yeah, that looks fun.
Yeah.
Okay, so here we can mark out the a and b terms. So the a squared will be equal to 49x squared. And then the b squared will be equal to 16. So a must be equal to 7x and b must be equal to 4. Then we could put it into the binomial. So we get 7x plus 4 squared. And then here we can solve that. We don't have to solve the whole thing. We can just solve for the middle term, but we're just going to solve for the whole thing anyways. So get 49.
Also, we should probably remember that A is plus or minus 7x and B is
Yeah.
plus minus 4.
Yes, that is kind of important in this question.
Yeah. Because both 4 squared and negative 4 squared gives you 16. So
Yeah, so we have to test for all of the negative signs as well. So
yeah.
here in the first one, we see that we end up with a positive middle term. So we can just stop right there and be like, that's the wrong one. And then we can move on to the negative. And then we see that this one matches. So this is the correct factored form.
Just if you're confused, what we essentially did is we took the first column and we set A to whatever the square root of this is. Then we took the third column and then we set B to whatever the square root this is. And then after we substitute these back into the binomial, we see if the middle term match. So if the middle term does match, then it is a perfect square trinomial, and if it doesn't, then it's not. So that's what we did. Okay.
Oh, Edward said, can you scroll up a little bit?
Can you scroll? Oh yeah, sure. A bit more, yeah. Yeah, no problem. Okay, so should we give them some examples to try?
Yeah, we should give them an example. We can do like x squared minus 10x plus 25.
Sure. Oh, whoops. So determine if this is a perfect square trinomial or not. X minus I squared. Yeah, so
Yes.
good job. It is a perfect square trinomial. So if we just lay out the form of a perfect square trinomial, we can match the first term, the first column, and then we get A is X. Then we match the third column, and we get B is plus or minus 25. So B is plus or minus 5. Then we just substitute A and B back into the form. So X plus 5 squared does not give you the original thing, but X minus 5 does. So this is a perfect square trinomial. Another one?
Yeah, we can give another one. We can do 9x squared plus 12xy plus 4y squared.
Sure.
Yep, really, you got it.
Yeah, good job. All right, do you want to explain it?
Yeah, sure. Okay, so we can write out the general expression for a perfect square trinomial. And then we can see that if we do the columns thing again, we can see that A is equal to 3x. And that B is equal to 2y. And then what we do is that we just put it back into the binomial expression. So we get 3x plus or minus 2y. And then what we do is that we just solve for each. And then we can see that for the first one, we do get a positive middle term and it does match. So that's the correct one.
So from here, we already know that it's a perfect square trinomial.
Yeah. And there is a correlation between the second term in the binomial and the middle term in the trinomial. So if the middle term in the trinomial is negative, then that means the b term in the binomial must be negative as well.
Yeah, so if this is positive, if this is a positive, then the middle term is also a positive. Is that what you're trying to say?
Yeah,
Okay, yeah.
I think that's correct.
Yeah, so
Wait, it says it in the notes here. Okay. Yes.
so 9x
Yeah.
squared minus 12xy. And if this is a negative sign, then the middle term is also negative.
Yeah, so I guess that's one way to skip the trial and error. So
Yeah. We can do one more example. What about this 16 plus 8x squared plus 16 plus x squared minus 8x. Is this a perfect square trinomial? Four minus x squared. Yeah, good job. It could also be x minus 4 squared, depending on how you prefer to write it. But yeah, that's correct.
yeah, so to solve this one, what we can do first is that we can organize it from descending degree. So we see that x squared goes first, and then we have negative ax, and then we have plus 16. And then we can match up the a and b terms. So in this case, a will be x. Oh yeah, you should just write that as well.
Yep.
And then a will be x, and b will be 4. Oh yeah, plus or minus 4. And here we can see that it's negative in the middle term, so we can kind of skip on the a plus 4.
True.
Yeah, we can just do a minus 4 or x actually, but
Oh,
yeah.
my bad.
It's fine. Do x minus
Yeah.
4 and we get x squared minus 8x plus 16, and it does match, so that is the factored form.
Okay, difference of squares.
Yes.
So the difference of squares is another type of binomial that you're going to encounter in high school. It's always a binomial. So what a difference of squares is that you have a binomial. The first term is a square and the second term is also a square. So for example, 4x squared minus 9. However, just because the two terms are both a square, it doesn't mean that they're always a difference of squares. So what a difference of square essentially means is a plus b just like what Alex said, a plus b times a minus b. When we expand this, we get a squared minus b squared. So a binomial is only a difference of square if it exists in the form of a squared minus b squared. Not a squared plus b squared, only a squared minus b squared. And usually the first term will be degree 2 and the second term will be a constant. So like, for example, we could do x plus 5 times x minus 5. We will get x squared plus 5x minus 5x minus 25. So we get x squared minus 25. Now, this is what we call a difference of squares. All right, David, do you want to do another example?
Yeah. We can do. Wait, which direction do you want to go from? Like the binomials?
Left to right.
Oh, left to right? Okay. We can do like x plus 3 times x minus 3. Okay, and then we could FOIL this out. We get x squared plus 3x minus 3x minus 9. And then we get x squared minus 9. That would be the difference of squares. Should we do one with a coefficient?
Yeah.
Okay. We can do like 3x minus 5 times 3x plus 5. And then here we do FOIL again. We get 9x squared. We get minus 15x plus 15x. And then we get minus 25. So our difference of squares is 9x squared minus 25.
Also, I think I've mentioned this, but in a difference of squares, it's always a negative sign in the middle. It's never a positive sign in the middle. So just be aware of that.
Yeah. If you're ever in doubt of what a difference of square is, just kind of parse out the name. We have a difference and it has squares with it. So
Oh yeah,
yeah.
that's true.
Name is kind of self-explanatory. So yes. Okay. We should try the other direction. Go from a
Sure.
yeah. We can have like 9x squared minus 16y squared.
Squared.
Minus 16y squared.
So just by looking at this, we know that it's a difference of squares because firstly, the first term is a square of 3x, and the second term is a square of 4y, and the middle is a negative sign. So this is a difference of squares. Then we just substitute these into the general form. So 3x plus 4y times 3x minus 4y. Okay. Another one?
We can go with something simple. Oh wait. Huh. Okay, we should do a fun one. X squared minus 7.
Huh, interesting.
Yeah. You guys can post in chat if that is a difference of squares or not. Yes. I mean, technically we could do root 7.
No, it has to be integers
Yeah.
though.
Okay, yeah,
'Cause
that's
then
true.
everything will be perfect square. I
Yeah.
mean, difference of squares.
We probably should have mentioned that on the start though. A
Oh,
and
yeah.
B is integers.
Yeah. So a and b has to be integers.
Or else you could just square root it. And then
True.
everything will be difference of squares.
Yeah. That'd be fun though.
Yeah, Edward, you're correct.
So how we know that this is not a difference of squares is we see that the second term is not a square. There is no integer value that will give you 7 when it's multiplied by itself. X minus root 7. Huh, yeah. We wish we could do that, but unfortunately they have to be integers.
Should we move on, or do you want to do one more example?
We could do one more. Actually, we should let them try out one.
Here, wait, should I make one up?
Yeah, sure.
Wait, do you want big numbers or not? Should we just do like a normal one?
Not like bigger than 50. 40
Okay,
more
okay.
for now.
Yeah, we can do 16x squared minus 49y squared.
Okay, yeah, that's manageable.
Yeah,
Didn't we already do this?
I think we did.
Oh wait, no, we didn't.
Wait, no, we didn't. Okay.
Oh.
Yes, convert that into the two binomials and put your answer in the chat. Yes, Edward, that is correct.
Yes.
And Groy. Okay, so we should do this one. So we could kind of see that the a would be the square root of 16x squared, which is, yeah, we should match that up. Okay, so you can see that a is 4x and that b is 7y. So we can just put it into the binomials. So we have 4x plus 7y, and then we also have 4x minus 7y. And yes, that would be the difference of squares.
Yep. How we know that this is a difference of squares for sure is that we see the first term, and that's a square of 4x. And then we go on to the second term, and that's a square of 7y. And then there's a negative sign in between. So we know for sure that it's a difference of squares. Okay. Should we go to variables, replacing terms?
What's the point of DOS? Sometimes it makes solving equations easier. Sometimes you'll encounter it, and then it'll be like much more easier to solve it if you like turn it into the binomials, for example.
Well, yeah, there's actually also like a more helpful, useful purpose for difference of squares. So I won't be explaining this in much details, but in a fraction, when the denominator has a square root in it, so for example, x minus root of 7, we tend to make the denominator all integers. So what we would do is multiply by x plus square root of 7. So this would be called a conjugate. And then we get the denominator to be x squared minus 7. So after we multiply itself by its conjugate, we get integer values for both terms. I think that's a more useful purpose for difference of squares. Wait, David, did we learn this in 10?
Rationalizing denominators, I think, yeah.
Oh, okay. I think we'll be covering that in the next few lessons. So yeah, rationalizing the denominator.
Yeah. For rationalizing the denominator, there's really like no good reason for doing it other than that mathematicians prefer to have like integers in the denominator. Wait, rationals, I mean.
Yeah, rationals are integers.
Yeah, okay, so we can move on. So sometimes when we have polynomials, instead of having variables, we could have more polynomials. So we could have something like x plus 1 squared plus 3 times x plus 1 and plus 2. So you can see that the x plus 1 could be an x, and that would be another polynomial, but in this case, it just put more polynomials inside. And you can actually still solve this. So what we could do is that instead of leaving it as like a polynomial, we could instead make it into a variable. So we could say that we have a variable y let y equal to x plus 1. And what we can do now is that we can rewrite the equation, but instead of x plus 1, we could rewrite it using y. So we got y squared plus 3y plus 2. And this kind of makes it easier to see the entire polynomial. So you can see that if we were to do the AB thing, a plus b would equal to 3 and a times b would equal to 2. So a will be 1 and b will be 2. So can rewrite it y plus a, y plus b, and a plus b will be equal to 3, and a times b would be equal to 2. So a or b could be 1, but a equals 1, b equals 2. And then we could do y plus 1 times y plus 2. And what we do now is that we kind of just put the x plus 1 into wherever y appears. And remember to put x plus 1 in brackets because it's kind of important when you have subtraction signs. So we just kind of put it in. We have bracket x plus 1 plus 1 multiplied by x plus 1 plus 2. And then we can just simplify. And then we just simplify that. And in the first one, we get x plus 2. And in the second one, we get x plus 3. And that'll be the factored form. Yeah, we should do another
So if you
example.
yeah, if you want to take a screenshot, you can take it. Okay, another example. What are you thinking?
Okay, let's do some negative signs. We got x minus 3 squared.
X 3 squared.
Subtract x minus 3 and subtract 2. So it kind of looks messy right now, but we can replace it with a variable. So we can say that let y is equal to x minus 3. And then we could just substitute y in wherever x minus 3 appears. We have y squared minus y minus 2. Wait, yeah, okay. And then we could do y plus a and y plus b. And here we have a plus b is equal to -1 and a times b is equal to -2. So a would be -2 and b would be 1. And then we could put it back in, y minus 2 times y plus 1. Too many colors.
True.
Yeah.
I just want to make it simpler by like substituting back into y.
Yeah, it looks
Like,
good.
that's why I'm doing the colors.
Yes. And then we could substitute back in the x minus 3. So we replace all the y's with x minus 3. X minus 3 minus 2 times x minus 3 plus 1. And then we just simplify these inside the brackets. We get x minus 5 and x minus 2.
Awesome.
Feel like that one's pretty simple.
Yep.
Should we do another example? There's this like fun one.
Which one is it?
If you scroll down right above the next topic.
Oh, okay, sure.
Yeah,
The
we
9a minus 5 one?
Yeah, that looks fun.
Okay, sure. Should we let them try this out?
Yeah, we should let them try this one out.
Okay. So factor this binomial or whatever you want to call it. Okay, since time is running a bit short and we still have a couple more topics to do, we will just explain this. Okay. I'll just use one color. Oh, 3 minus.
That is.
It's close. You
Yeah.
realize that it's a difference of squares, so that's good. But you have a -4, right? Yeah.
Yeah.
It should be +2 and -2 in the two brackets. That's fine. David, don't explain it.
Oh yeah, sure. Okay. So the first thing that we can do is that we can just set a variable. So let y is equal to a minus 5. And then we just replace all a minus 5 with the variable y. So we get 9y squared minus 4. And here we can see that it's actually a difference of squares. So a will be equal to 3y and b will be equal to plus or minus 4. Oh, wait, no, wait, I'm thinking of the wrong thing. Yeah, 3y plus 4 and 3y minus 4.
+2 -2.
Yeah, wait, okay, yeah,
I think.
okay.
Yeah.
Well, it's a little bit of
That's
a moment right there. And then now we gotta sub back in the, wait, what was it, a minus 5? So we
Yeah.
get 3 times a minus 5 plus 2 and 3 times a minus 5 minus 2. So in the end, we get 3a minus 13 and 3a minus 17.
Fast calculations.
Yes.
Okay. Oh yeah, you forgot the short. Yeah. So 3 minus a minus 5. Wait.
Yeah, I think Edward might have messed up. Like he might have forgot that it's multiplied between the 9 and the a minus 5.
Oh yeah, Edward. It's actually 3 times a minus 5, not plus minus. Okay, yeah, that's our. Yeah. Okay. All right. It actually looks like we've only got one more topic to do.
Well, 2
which
more.
is solving 2 more. Oh really?
Wait, 3 more.
Oh, 3. Well, they're all essentially about the same thing, solving
Yeah.
equations.
Okay. Do you want to
So
explain this one?
technically, yeah, sure. So technically, one more. Solving equations. For solving equations, we can get a question that looks like this. Okay, what should I do? Okay, x squared plus 6x plus 10 equals 1. So when we say solving equations, what we mean is finding the x value that will make the equation true. So for any quadratic equation, the first thing we want to do is make the right hand side 0. So we want to make the side 0. How we would do is subtract 1 from both sides. So for example, x squared plus 6x plus 9 is equal to 0. Now that the right hand side is 0, we want to factor the left hand side. So since we can tell that this is a perfect sort trinomial, we can get x plus 3 squared is equal to 0. Now this is the tricky part. For this left hand side to be 0, x plus 3 must be 0. Because only 0 times itself is equal to 0. So x plus 3 is 0. So x is -3. This is the only solution to this problem. We can have another example. So like, let's do x squared plus 2x plus 9 or minus 9 is equal to 2x. Now in this case, we want the right hand side to be 0 as well. So we subtract 2x from both sides to get x squared minus 9 is equal to 0. Now we can tell straight away that this is a difference of squares. So we get x plus 3 times x minus 3 is equal to 0. And the only way that we can get 0 is if one of these binomial is a 0. So either x plus 3 is 0 or x minus 3 is 0. So the answer will be x equals 3 or -3. So I guess the main thing you want to know is that we always want to make the right-hand side 0 and then factor the left-hand side. So David, do you want to give more examples on this?
Yeah, sure. Do you want a long one?
We could try that, yeah.
Yeah, okay, we have like 2x squared minus 5x plus 2 equals to -7x plus 1. Okay, should I explain for this one?
Oh yeah, go ahead.
Yeah, okay. So we see that, okay, well, when it comes to me, I don't necessarily leave the right side 0, but what I do is that I like to keep the highest degree term positive. So in this case, 2x squared. I would like to keep that positive, and to do that, we just move everything to the left side. So still keeps the right side 0. So what we do is that we just add 7x to both sides to remove it, and we get 2x plus 1, and then yeah, we also subtract the 1. So now what we do is that we just factor this one out, and hold up, yeah, let's use your method. We
I
have
don't think you can factor this.
that's fun.
Wait, give me a sec.
This is a weird question. Why is this on
It
here?
is. We can do -8x. Like,
Yes, good idea.
wait, does that even work? Okay, so 2x squared plus 3x plus 1 is equal to 0. 2x, x. Okay, I think that works.
Yeah.
Okay.
Okay, let's put the plus a and plus b, I guess. Plus a plus b, and a plus 2b must equal to 3, and a times b must equal to 1. Wait,
Yeah.
okay, wait, my mind
A-
stopped working.
A and B are
Okay, we
equal
have,
to 1.
yeah, and then we have, I think 1, a1 and b1, yeah.
Yeah.
Okay. Oof, the brain lag, okay. And now we just put it back into the equation, and we get 2x plus 1 times 2x plus 1. And here, one, actually both, okay, we have two possible answers here. So either 2x plus 1 equals 0, so we can put that equal to 0, and then we'll just solve for that. And then we move the -1 over, and we get x equal to -1 over 2. So that's one of the possible answers. And the other one is if x plus 1 is equal to 0. So x is equal to -1. So our two possible answers are -1/2 and -1.
Yes.
So choose another question you want to.
Do you have a question?
We can try another one. Maybe this one will make more sense.
Sure.
Yeah, we can choose 7x squared plus 15x plus 15x plus 9 is equal to x squared minus 4x minus 1. So it might be possible. Okay, well, let's just move everything to the left side. So we get, move the x squared over, we get 6x squared, and then we add the 4x, get 19x, and then we add the 1, which gives us plus 10, and that equals to 0. And that one might be solvable, but let's try it anyways. Okay, so we can use Kevin's method. We have 3x. Okay.
Oh, we can do 6x.
Okay, yeah, that's a good idea. 6x plus a and
Okay.
x plus b. And then we can try that one first, I guess. And then we can do, yeah, okay, we can do x, a plus 6b is equal to 19. And then a times b is equal to 10. And mine stops working.
I don't think there is a solution for this one. Yeah, there isn't. So we can do 3x and 2x, I guess.
Yeah, 2x plus a and 3x plus b. And we get 3a plus 2b is equal to 19. And a times b is equal to 10. Wait. I think a is equal to, Wait a
I think A
minute.
is 5. I think
A-
A is
A-
5 and B is
B is 2. Okay.
Yeah.
Yeah, can't factor. Nice. And then we see that 2x plus 5. So that's one of our possible answers. 2x plus 5 is equal to 0. So we can turn that into an equation. 2x plus 5 is equal to 0. And we can move the 5 over, and we get x is equal to negative 5 over 2. So that's our answer. And then there's another one, which is 3x plus 2 is equal to 0. So we get negative 2 over 3. And those are our two answers.
okay. Should we do like an easy but fun one? Like x minus 5 to the power of 9 is 0?
Sure, we can do that one.
Or we could even do like to the power of 100 is 0.
Yes. Wait, let's let them do it.
Yeah.
Here, guys, if you know the answer, put it in the chat. Oh, you're so close, Edward.
Super cool.
There. Yeah, that's the correct answer.
Nice.
Yeah, so if you're multiplying stuff together and even one of the values is equal to 0, then the whole multiplication is equal to 0. This is a bread and French moment.
Pain. All right. Okay. Do you want to do the third one or go? Should we go on to worksheets?
Yeah, let's do some worksheet questions.
Sure.
Do you want to do number 1?
That looks like brute force.
Can't. Maybe we can try something.
But yeah, like number 1. Are you doing number 1?
Well, we can have like negative, well, not negative, but like 2 times a times 5 is equal to 180. If you get what I mean.
Okay.
Yeah.
Yeah. Okay. Sure.
Yeah, since this one's a perfect square trinomial, we can use like the a squared plus 2ab plus b squared thing. Oh, it's not equal.
Oh,
It's fine. So here we know that b is equal to 5.
negative 5 because this is
Oh
negative.
yeah, true. Okay, totally forgot about that. But we can also do the 2ab thing. So 2 times a times negative 5 must equal negative 180. So we can just do some math. We get negative 90 and then, wait, 180. Yeah, okay. Confused.
Yeah.
A is equal to 9x. Wow, you're fast.
Oh.
Yes. Yeah. Okay, so A is equal to 9x.
Wait, no. A is 18,
Wait.
I believe. Because yeah, A is negative. A is 18. Yeah. X.
Wait.
Yeah.
And then yeah. So
So
K is 18 x in brackets squared. I don't know what 18 squared is. Here, yeah. 324. 324 x squared. Oh, 324.
oh, 324. Sorry.
Yeah, it's fine. And yes, K is 324 x squared. So that was interesting. Should we do another one? We have time.
Yeah, I found a fun one that I want to do. Like
Ooh, okay.
this one.
Wait, why is there a red line?
Hmm?
Edward just posted in chat. Wait, why is there a red line? Oh, first question.
Oh, yeah, because I wanted to emphasize that it's a negative sign, so B has to be negative.
Yes.
Yeah. I'll just write it like negative. I think we actually did number 4 like last week, but I think it's pretty fun. We can try it out.
I don't think we did it last week.
Oh yeah, because there's some grouping and some difference of squares.
Yeah.
Okay. Okay. Yes. You could actually factor that even further though. So it's a difference of squares. Okay. David, do you wanna do it or should I do it?
I'm still doing it right now, so
Okay.
I think
can
you should
just
explain it.
Sure. So using the grouping method we learned last time, we can group the first two terms together and the last two terms together. So we have k to the power of 6 times k squared minus 1. Then on the second term, in the second group, we can actually express it as negative k to the power 4 minus k to the power of 2, which is just, you extract the k to the power of 2 out and you get k squared minus 1, I believe. Yeah. Okay. So then we see that we can combine the two coefficients since they are like terms. So k to the power 6 minus k to the power of 2 times k to the power of 2 minus 1. On the left side, we can extract the k to the power of 2 out. So we get k to the power of 2 times k to the power of 4 minus 1. On the right hand side, we see that it's a difference of squares. So it's k plus 1 times k minus 1. However, rather than change sign. Oh, okay. However, we see that the term is actually another difference of squares. So we have k to the power of 2 times k to the power of 2 plus 1, k to the power of 2 minus 1, k plus 1, k minus 1. And then we see that this is another difference of squares. So we end up getting k squared plus 1, k plus 1 squared, k minus 1 squared. It's a long one, but essentially you just have to group them together and then keep expanding the difference of squares or keep factoring out the difference of squares. Okay. All right, David, what's our next lesson?
I think it's coordinate geometry.
All right. So yeah, next week we're gonna change focus to some coordinate geometry, which will be fun. Well, thank you all for coming today. We appreciate it. And see you next class.
Yes, see you guys later.